Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 60. Page number 60, and today is our lesson number 69. Or page number 160 is what I meant to say. Lesson number 69. Problem number 64. Let's take a look at it. Problem number 64, which is on page number 161, not page 160. It's a good thing I checked. Page 161. Problem number 64, the very first problem on the page there. So we have apples that are being sold for 70 cents each, we are told. We have bananas which are being sold for 50 cents each, and we are told that the total amount of money that is spent is $6.30. I'm expressing everything in 30 cents because I hate dealing with decimals. The question simply is, if that were the case, if somebody walked in the store and spent $6.30 buying apples and bananas, we are told that apples are 70 cents each and bananas are 50 cents each. Question is, how many apples and how many bananas did the person buy? Now, on the first glance, it may seem like a very strange question here because we are only given one equation with two unknowns, apples and bananas. Don't just stop there, just start setting it up and something will click. Something will click, because obviously they're not going to ask you to do something impossible. There has to be something in the problem, some limitation, some constraint, something in the problem that will help us get over this problem that there's only one equation and yet there are two variables, apples and bananas. Let's find out. Here's the solution. Here's the solution. Let A be the number of apples bought. Similarly, let B be the number of bananas bought. Now, if that's the case, then the equation that emerges is that since apples cost 70 cents each and we're going to buy A apples, if we were to buy 3 apples, it will be 3 times 70. If you buy 5 apples, it will be 5 times 70. If you buy A apples, it's going to be A times 70. Plus bananas, which are 50 cents each, and we're going to buy B of them. And that has to equal 630. Now, the very first thing that I want to do before we do anything at all is I see a 0 here, I see a 0 there, I see a 0 there. Let's divide the entire equation by 10 and knock out the zeros. So 7A plus 5B equals 63. Let's solve for B. So 5B equals, now the reason I want to keep the B here and bring the 7 over there is because, as you can see, well, actually I was wrong. Let's not keep the B here. Let's keep the E here so that when we divide by 7, we can divide 63 by 7 very easily. 63 is not going to divide by 5. 63 is not going to be divisible by 5. I changed my mind. Let's keep an A on this side. It doesn't really matter. You just have to do whatever is smarter, whichever is easier. 7A equals 63 minus 5B. So far so good. Let's divide the entire equation by 7, and A equals 63 divided by 7 minus 5 over 7 times B. 63 divided by 7 is 9, so it's 9 minus 5 over 7 B. I'm going to continue here. Let's continue up here. So this part right here, this equation is going to come on the top. So number of apples that are bought equals 9 minus 5 over 7 times B. Now listen carefully. Now since A and B are both integers, this is where you have to put your thinking cap on, because the rest was simple algebra. Now we have to do some analysis here. since A and B are both integers, because obviously the guy is not going to sell you 3/10 of a banana, he's not going to sell you a 3/7 of an apple. You have to buy the whole freaking apple. A and B are both integers. Therefore, I'm going to erase this part here. Therefore, this B that we see here, because obviously 7, we cannot divide 5 by 7. In order for this entire thing, therefore, in order for the quantity 5/7 times B to be an integer, that tells that B must, that implies that B must be some multiple of 7. B has to be some multiple of 7 because this quantity 5/7 times B has to be an integer, because that's how many apples we are buying. That represents the apple. 9 minus that amount. 9 is an integer. This has to be an integer. So B cannot be 13. B cannot be 13 because then we cannot divide 13 by 7. We cannot divide 5 by 7. B can be 7. B can be 7. 7 divided by 7. B can be 14. We can divide 14 by 7. B can be any multiple of 7, but it has to be multiple of 7. B must be some multiple of 7. Let's continue. Let's pretend, let's assume, we're going to continue here. Let's assume that B is equal to 7. We're just assuming it. Okay? It's just an assumption. In that case, bananas would cost 7 times, what was the price of bananas? How much did the banana cost? 50 cents. 7 times 50 cents, or $3.50. $3.50. The total amount that was spent was $6.30. This was the total. If we subtract $3.50, 13 minus 5 is 8, 5 minus 3 is 2. Voila, 280 cents left. 280 cents is just enough. 280 cents is just enough to buy 4 apples. Because apples cost 70 cents. 70 cents times 4. We are told that apples cost 70 cents. That is exactly what must have happened. Because obviously, note that since we figured out that B has to be some multiple of 7, note that B could not possibly be 14. It could not possibly be 14 because we are told that bananas cost 50 cents. 14 times 50 cents would have been $7. We only have $6.30 to begin with. The total amount that we have is $6.30. To say nothing of the fact that the question specifically tells us that the person is buying both apples and bananas. He can't even buy this. That's not even enough money to buy the bananas. If you were going to buy 14 of them, because it has to be multiple of 7, because of the fact that this quantity B has to be divisible by 7, because 5 cannot be divided by 7. That's it. We're done. So the person must have bought. Where can I write it? Person must have bought 4 apples and 7 bananas. 4 apples. The 4 apples will cost $2.80, and the 7 bananas are going to be $3.50, making it a grand total of a shopping spree of $6.30. That's it. Should we do one more? Should we do number 65? Let's do 65. 65 is quite straightforward. In question number 65, you're just trying to see if you understand how to manipulate exponents. It's very straightforward. Let's do it together. Let's say we are done with this one. That's it. I'll give you a couple of seconds. That's it. Alright. Number 65, as I said, they're just trying to see if we understand the concept of exponents. So we are told that the distance between the sun and some planet is 2.3 times 10 raised to 14 inches. Question is, how many kilometers is that? And we are told that 1 kilometer equals 3.9 10 raised to 4. I'm going to change the marker for a second. Well, not for a second, I'm going to change the marker period. So that's all it is. If 1 kilometer equals that much, and this is how much total is, all we have to do is divide. In order to figure out the distance, we just have to divide one by the other. 2.3 10 raised to 14 over 3.9 10 raised to 4. Now 10 raised to 4, 10 raised to 14 divided by 10 raised to 4 is simply 10 raised to 10 raised to 10. So we end up with 2.3 over 3.9 times 10 raised to 10. 2.3 divided by 3.9 is same as 23 divided by 39 10 raised to 10. And 23 divided by 39 is going to be some decimal. It's going to be some decimal times 10 raised to 10. And in order for us to get rid of the decimal, it's going to be 1 point something times 10 raised to 9. The only answer choice, the only answer choice that we see with 1 point something. How are the answer choices laid out? There you go, 1 point something times 10 raised to 9. Why 10 raised to 9? It was 10 raised to 10, it became 10 raised to 9 because whatever the decimal is, we are moving the decimal by one space. You understand? For example, if it's 0.89 times 10 raised to 10, that's some decimal. And if I want to remove the decimal place one space, it's going to be 8.9 10 raised to 8. Because we're taking the 10 from here and multiplying it by 0.89. That's what's going on here. So it's 23 divided by 39 is some decimal. I don't know what the hell it is. I'm not interested in it. But it's some decimal times 10 raised to 10. And which is same as 1 point something, whatever it is. 1 point something. It's going to be because it's going to be 230. It's going to be 230 divided by 39. Whatever that is. It's going to be 1 point something, or it's not going to be 1 point something, is it? Or whatever it is, it's going to be something, some amount. It's not going to be 1 point something. I just realized it's going to be 230 divided by 39. That's what it's going to be exactly. I shouldn't say 1 point something. It's going to be 230 because it's 23 divided by 39 10 raised to 10, which is same as 23 divided by 39 10 raised to 10, which is same as 230 divided by 39 10 raised to 9. Now the only answer choice that we see with 10 raised to 9, the only answer choice that I see with 10 raised to 9 is B. The answer is B. It has to be. It's the only answer choice that we see there with 10 raised to 9, and that's all it is. And it says 5 point something, which makes sense because 200 divided by 40 would have been 5. Since we are dividing it by something less than 40, it's going to be something more than 5. And since the top is not 200, it's 230, it's going to be 5 point something and then 10 raised to 9, which is exactly what the B says. The only two answer choices with 5.9 are B and E, and obviously the exponent is not going to increase, and it's not going to go from 10 to 11, it's going to go from 10 to 9, as you can see here. And it was 9, it became 8 when you move the decimal place. So this one has nothing to do with it, this was just an example. That's it, we're done with this one. Alright? I will see you tomorrow, and we will continue our journey. Bye now.